We'll now discuss bonding and pay particular emphasis to covalent bonds. So recall our periodic table and observe the fact that in column 8 we have valency 8, and that cuts across helium, neon, argon. And this was how we represented all our electrons. Now, in covalent bonds, you have shared electrons, and it's always between non-metallic atoms. So used by nature, human body, plants, methane gas. So, for example, observe water, carbon dioxide, and CH4. CH4 is the simplest form of organic compounds, and then it grows like a chain, but that's how the human body is built. So you breathe in the oxygen, and then you output carbon dioxide, and the body converts it into water. So these transitions happen because these compounds easily share electrons with other atoms in those categories. So let's take water. You have hydrogen, which has one valence electron, and you have oxygen, which has 6 valence electrons, and they both want to reach the octet, satisfy the octet rule, i.e. hydrogen wants to reach 2, the duet, and oxygen wants to reach 8, which is the octet. So let's see that you have an oxygen atom with 6 electrons and hydrogen atoms with 1 electron each. So the hydrogen electron will be shared with the oxygen, that's 1, and the other one is shared with the other hydrogen atom. So both of them have reached duet, and oxygen has reached octet. This is the structure of H2O. And now another way to represent this is without the circles, is to show the shared bond between oxygen and hydrogen and the other shared bond. These are both single covalent bonds, also represented by a single line. So on that line you have 1 electron belonging to oxygen, 1 electron belonging to hydrogen. Let's now do methane, the simplest form known to nature. So here we have hydrogen that wants to go to helium and carbon that wants to go to neon. So now here's methane. So carbon is looking for 4 electrons to satisfy the octet rule. Now it'll take 1 electron with an hydrogen atom. So the hydrogen atom has reached duet, but carbon is now at 5. Does it with a second hydrogen atom. Now it reaches 6. Third hydrogen atom reaches 7. And now it's satisfied the octet rule. So that's how CH4 is structured. Another way to represent this, just to show without the circles, is to show those shared electrons. So now you have 4 bonds, but because they're sharing 1 electron each, that is known as a single covalent bond. Now let's look at carbon dioxide. Now carbon wants to reach steady state of neon. Oxygen also wants to reach the same steady state of neon. So what do you have? Carbon. And now it shares 2 electrons with a single oxygen. So the oxygen has now reached its octet, and it does the same with another oxygen atom. So now all of them have reached the octet state, and this is another way to represent the shared electrons between these atoms, also represented with this line. Now you'll see that between oxygen and carbon there are 2 lines. That's known as a double covalent bond. Now let's look at oxygen. Both the oxygen atoms want to reach the neon octet. So you have 1 oxygen, you have a second oxygen, and they combine to share 2 electrons each to form O2. And if you remove the circles and go with the other representation, you find that oxygen has a double covalent bond.